Octal number system became widely used in computing when systems such as UNIVAC 1050, EDP-8, ICL 1900, and IBM mainframes employed 6-bit, 12-bit, 24-bit, or 36-bit words. Octal was ideally abbreviation of binary for these machines because their word size is divisible by 3. And octal is known as the base 8 number system because it uses 0 to 7 digits to represent an integer. Now let's see the differences between octal and decimal. So on this table, we have two columns, the columns for decimal numbers and the columns for octal numbers. For decimal numbers 0 to 7, it is the same as with the octal numbers from 0 to 7. However, in decimal, after reaching 8, in octal it becomes 10. And it will continue until 15 of decimal. So 8 in decimal becomes 10, 9 becomes 11, and 10 becomes 12, 11 becomes 13, and this will keep on going until 15. And 15 in decimal is 17 in octal. So after reaching the 8th digit of decimal, so 1, 2, 3, 4, 5, 6, 7, 8, the ninth digit becomes 20. Just like the same pattern with the first 8 digit in decimal. So let's count 1, 2, 3, 4, 5, 6, 7, 8. After 8, the number becomes 10. So the same goes with 16. It becomes 20. So meaning every after 8 digit, the pattern follows the same sequence. After first 8 digit, it will become 10. Then another after 8 digit of decimal, it will become 20 in octal. Then another 8 digit of decimal, it will become 30 for octal, and so on. Now let's see how octal numbers are represented in decimal. Let's have this example, 402.023. We will start solving this by starting with the whole number part. Let's begin with 2. So we will multiply 2 with its base number and raise the base number with 0. And then plus 0, and that is the second number, and multiply 0 with the base number 8 raised to 1. And then plus the third number, which is 4, multiplied by the base number raised to 2. So as you can see, the exponent are incremented by 1, just like the way we solve the binary decimal. So after completing the whole number part, we will now proceed to the fractional part. So we will multiply 0, because 0 here is the first digit, multiply this with the base number, and raise that with negative 1, plus 2 times 8 raised to negative 2, plus 3 times 8 raised to negative 3. And then let's start simplifying this. Let's begin with this first digit, 2 times 8 raised to 0. So this becomes 2 times 1, plus 0, because any number multiplied by 0 is always 0, plus 4 times 8 raised to 2. This becomes 4 times 64, because 8 times 8, this will give us 64. Now let's work on the fractional part. 0 times 8, and that is 0, plus 2 times 1 over 8 raised to 2, plus 3 times 1 over 8 raised to 3. Now, if you're wondering why we have this one and why we were able to turn negative 2 to positive 2, you can watch our video for binary to decimal, because on that video I've already explained the reason why we have to add 1 here. Okay, so let's continue. So next, let's simplify this. 2 times 1, that is 2, plus 0, and 4 times 64, that is 256. Now let's work on the fractional part on this side. So 0 plus 2 times 1 over 64 plus 3 times 1 over 512. Okay, so we are done with the whole number part. So what we will do is just to copy everything from there. and then we will continue solving the remaining fractional part. Okay, 0, because we are already through with this, so we will just bring this down, and then plus 0.03125, because 2 times 1 gives us 2, and 2 divided 64, it will give us 0.03125. And then the same thing will happen here also. 3 times 1, that is 3, and 3 divided by 512. So this will give us 0.0058593. And then after simplifying everything, let's add these numbers. So after adding these numbers, this will give us 258,0371. So this means that 402.023 is 258.0371 in decimal. So we have a base number 10. All right, so let's have another example. This time let's try 6132.51. Okay, let's begin solving this with 2. 2 times 8 raised to 0 plus this one. 3 times 8 raised to 1 plus here 1 times 8 raised to 2, and then plus 6 times 8 raised to 3. Okay, then let's work on the fractional part. 5 times 1 raised to negative 1, or 5 times 8 raised to negative 1, plus 1 times 8 raised to negative 2. And then let's simplify each of these. Let's start with this part. So this becomes 2 times 1. Then this part, this becomes 3 times 8. And then this part, this becomes 1 times 64. And then the last one, this becomes 6 times 512. Now let's work on the fractional part. Let's start with this. 5 times 8. This becomes 5 times 1 over 8 raised to 1 plus 1 times 1 over 8 raised to 2. So now let's proceed simplifying this. This becomes 2. This becomes 24. This becomes 64. And this becomes 3072. Now let's work on this part. So let's simplify this. So this becomes 5 times 1 over 8. Let's continue. This becomes 1 times 1 over 64. Okay, so let's just copy everything from the whole number part. And then let's work on this. 5 times 1 over 8. And this will give us 0.625 plus 1 times 1 over 64. Then this will give us 0.015625. And then let's add them all. And this results to 3162.6406. This is now the equivalent of this one, 6132.51. So this is now the decimal form. So 3162.6406. That is the decimal. Okay, decimal. All right, so that's all for this video, and see you in the next lectures.